We're going to work on an ALEKS problem that deals with preparing a strong base solution with a given pH. In this example, a chemist must prepare 600 milliliters of potassium hydroxide solution with a pH of 13.70 at 25 degrees Celsius. He will do this in 3 steps. He will fill a 600 milliliter volumetric flask about halfway with distilled water. He's going to weigh out a small amount of solid potassium hydroxide and add it to the flask. He will then fill the flask to the mark with distilled water. We're asked to calculate the mass of potassium hydroxide that the chemist must weigh out and round our final answer to 2 significant figures. So we want to try not to get overwhelmed with the unnecessary information and just focus on the information that we do need. So the first thing I want to do is come up with a balanced chemical equation. Potassium hydroxide is a strong base, so when I dissolve it in water, it will completely dissociate into its cation and hydroxide. Once I have my balanced chemical equation, I can go ahead and start off listing my given information. They give us the volume of our solution, 600 milliliters. But I'm going to go ahead and convert that to liters. They give us the pH, and they're asking us to solve for the mass of potassium hydroxide. So the first thing I want to do is solve for pOH. So I want to relate my pH to my pOH since this is a basic solution. So pH plus pOH equals 14.00. Plug in my pH, and I get pOH equals 0.30. Now that I have my pOH, I can solve for the concentration of OH minus. pOH is equal to the negative log of the concentration of OH minus. And the concentration of OH minus is just 10 to the power of negative 0.30. And I want to make sure that I don't round too early, so I'm going to take this out a few more digits than I really need to. Okay, now that I have the concentration of OH minus, I want to remind myself that concentration is just molarity, which is moles of solute over the volume of solution in liters. So I'm going to plug in some of my numbers here. And I can go ahead and solve for now moles of OH minus. Okay, we got to go a little further. We need to solve for grams of potassium hydroxide. All I did right now is solve for the moles of hydroxide. So I'm going to come up with a roadmap. I want to convert moles of hydroxide to grams of potassium hydroxide. I'm going to need the balanced chemical equation to do this. I'm always going to start off with my given number. So moles of hydroxide in the numerator, moles of hydroxide in the denominator. Take a look at my balanced chemical equation. For every 1 mole of hydroxide, I have 1 mole of potassium hydroxide. Moles of potassium hydroxide is in the numerator, so now I've got to put moles of potassium hydroxide in the denominator. Take a look at the periodic table. 1 mole of potassium hydroxide is equal to 56.1055 grams of potassium hydroxide. Our final answer should be in 2 significant figures, so this will equal to 17 grams of potassium hydroxide. Let's take a look at another example and another way of doing this. In this example, a chemist must prepare 550 milliliters of sodium hydroxide solution with a pH of 12.90 at 25 degrees Celsius. He will do this in 3 steps. He will fill a 550 milliliter volumetric flask about halfway with distilled water. He will weigh out a small amount of solid sodium hydroxide and add it to the flask. He will then fill the flask to the mark with distilled water. Calculate the mass of sodium hydroxide that the chemist must weigh out and round our final answers to 2 significant figures. Again, we want to try not to get overwhelmed with the unnecessary information and just focus on what we actually need. So let's start off with a balanced chemical equation. Sodium hydroxide is a strong base, so when I dissolve it in water, it will dissociate completely to its cation and hydroxide. So we've got a balanced chemical equation. The next thing I want to do is list my given information. They've given us the volume of solution, 550 milliliters, and I'm going to go ahead and convert that to liters. And they've given us the pH, and we're asked to solve for the mass of sodium hydroxide. Since they've given us the pH, I'm going to go ahead and relate that to my concentration of H3O+. Remember that pH is equal to negative log of H3O+. Plug in my pH. So the concentration of H3O+ is just 10 to the power of negative 12.9. And remember not to round too early, round at the very end. Now that I have my concentration of H3O+, I want to try to go in the direction of the concentration of OH-, since this is a basic solution. I can relate the concentration of H3O+ to the concentration of OH- using the Kw formula, which is Kw is equal to the concentration of H3O+ times the concentration of OH-. Kw is a constant that's given. I can go ahead and solve for the concentration of OH-. Now that I have concentration, I want to remind myself that concentration is just molarity, which is moles of solute over liters of solution. And now I can solve for the moles of hydroxide. Okay, we're almost there. Now we need to convert moles of hydroxide to grams of sodium hydroxide. I'm going to give myself a roadmap just to help me keep things in order. So I'm going to go from moles of hydroxide to grams of sodium hydroxide. Always start with my given. Moles of hydroxide in the numerator, so moles of hydroxide in the denominator. Take a look at my balanced chemical equation. For every 1 mole of hydroxide, I have 1 mole of sodium hydroxide. Moles of sodium hydroxide in the numerator, so now moles of sodium hydroxide in the denominator. Take a look at the periodic table. 1 mole of sodium hydroxide is equal to 39.9970 grams of sodium hydroxide. They want our final answer in 2 significant figures, so this equals to 1.8 grams of sodium hydroxide. Now there are two ways of working these type of problems out, but after looking at ALEKS, I see that they prefer this method when solving for these type of problems. So if you use this method, this will ensure that the last few digits round correctly to what ALEKS is given as an answer. Good luck and keep practicing.